I'm going to solve a numerical problem which is very different and it is related to transformer. Okay, what is the problem? Let's start. The problem is the primary winding of a step down transformer has 770 and it is supplied with 6 ampere 220 volt mains. The secondary winding produces 110 volt. Calculate the number of turns in the secondary winding. Also calculate the amount of electrical energy consumed in kilowatt hour by the primary winding of the transformer in one day. This numerical problem is a little different than normal numerical problem because we are also related with the consumption of electrical energy in the transformer. That's why I'm going to solve this a little differently. This is different and so we are going to solve it. Okay, first we have to write the given. Look at this. The primary winding of a step down transformer has 770. That's why I'm writing primary winding. It means number of turns in primary coil, that is 770. And it is supplied with 6 ampere 220 volt mains. What it mean? It means current in the primary winding, which is denoted by I, is 6 ampere, and primary coil is supplied with 220 volt, and that's why we can write primary voltage Vp is equal to 220 volt. The secondary winding produces 110 volt. It means secondary voltage that can be represented by Vs is equal to 110 volt. Calculate the number of turns in secondary winding. We are writing question later, but we have to write for first all the given. Also calculate the amount of electrical energy consumed in kilowatt hour by the primary winding of the transformer in one day. Here time is also given, that is 1 day, and we are converting it into hour, 24 hour. Now the question is calculate the number of turns in secondary winding. And secondary winding that can be represented by Ns, how many turns? And there's another question also, electrical energy consumed in primary winding. Now how to solve this numerical problem? If we have written all this given, then it becomes easy to solve the numerical problem. Now let's start. We have what we have, Ns by Np equal to Vs by Vp. What it mean? It means the number of turns in secondary coil divided by number of turns in primary coil is equal to voltage in secondary coil upon voltage in primary coil. The ratio of number of turns in secondary coil and primary coil is always equal to the ratio of voltage in secondary coil and voltage in primary coil. So look at this. Np is given here 770, it is written in place of Np, and Vs is 110, here it is, and Vp is 220. Writing all this, now we can go through simple calculation. 110 divided by 220 becomes 1 by 2, volt cancel. Now Ns is equal to 770 is, if taken to right hand side, it goes to numerator and 2 remains in denominator. That's why number of turns in secondary coil becomes 385, and this is one of the answer of the question. That means number of turns in the secondary winding is 385. Now we have to go forward again. Power equal to current into voltage, and current in the primary coil is given as 6 ampere. Primary coil current is 6 ampere and voltage in primary coil is 220 volt, and when we multiply these two we'll get 1320 watt, and since we want kilowatt, that's why it is when divided by 1000 we get the value in kilowatt, that is 1.32 kilowatt. Now we have to use the equation, another equation, what electricity consumed equal to power into time, and in place of power 1.32 kilowatt and time is 24 hour. It is already given here. Now when we multiply all this, then what comes? 31.68 kilowatt hour. And this is our final answer. That's why, therefore, the amount of electrical energy consumed is 31.68 kilowatt hour, and this electrical energy is consumed in primary winding. This way we can solve this problem. This type of problem is important for SEE examination. Normally this equation is used, but here a little different. Electricity consumed by transformer is also asked. That's why we are doing all these. Okay, this much for today.